Alright, welcome back, ladies and gentlemen. Now we're going to be moving on to section 4.6. So for day one of this, we're going to start graphing tangent and cotangent functions by hand. Alright, first of all, basically just, sorry, the picture is a little bit ahead of my words, but here we go. To graph tangent and cotangent functions, first of all, I'd like you to graph tangent on your calculator, and depending on your particular model of calculator and your software, you should get something that looks roughly like the picture I have down here. Alright, now what you do have to recognize as we're doing this, especially again depending on whether or not your calculator doing these vertical lines are actually asymptotes. If you kind of remember our various unit circle values for tangent, every now and then you get an undefined value, and that's basically what's showing up right here as an asymptote. So just kind of coloring these guys in. Wow, I missed a lot there, but I think you get the idea. Alright, wow, missed really bad that one. Okay. But anyway, so we really have some asymptotes. So the real graph of the tangent is these little blue squiggles right here that I haven't covered over in red. In addition to them, they do keep going on forever. So realistically, these are going to have little arrows, again showing the infinite rising or falling of each little squiggle part of the graph, if you will. All right. Now, of course, yay, the calculator can do it, but we need to be able to do it by hand. So let's take a look at how that actually comes about. Okay, so in order to figure out exactly why tangent looks the way it does, let's take a look at some of the values of tangent theta at every pi/4 on the unit circle. Alright, for instance, again, starting out at 0, well, tangent of 0 is actually 0. So for that previous one, you can see that's why it passes through the origin. Okay, and I'm picking pi/4 because tangent of pi/4 is actually equal to 1. So I'm going to use a little tick mark here on my graph. That'll be a 1 right there, and because it's going to come in handy, I'll put a little -1 down here for now. Alright, so as I was saying, there's pi/4, and at pi/4, I'm equal to 1. Okay, once we make it up here to pi/2, though, again, just another pi/4 along the circle, this is actually where I hit undefined. So basically I'm at 0, I'm at 1, I'm at undefined. And so that's at pi/2, and undefined is again where those asymptotes showed up. And basically as we continue around the circle, okay, as I get over to the next pi/4, which is a 3 pi/4 now. Alright, okay, I'm over here at 1 again, but again, since I'm in the second quadrant, it's really a -1. So I should have a dot right here. Unfortunately, it's right about where my 4 is, but let's go to the land of make-believe and assume that looks good. Alright, continuing around the circle at positive pi. Pi right there, we hit 0 again. Alright, continuing along. Again, now third quadrant tangent's positive, and at a 45-degree reference angle, which in this case is actually 5 pi/4, and we're sitting on +1 again. And then as we make it over here at 3 pi/2, and in order to do so, I'm going to extend my graph just a hair. So 3 pi/2. Again, notice that I get down to the undefined again because my y/x has an x of 0. And there you go. So let me fill that in. -1, 0, +1, and again we get back to undefined. And just for the sake of completing things, when we get over there, we're at -1 again. So notice a pretty definite pattern with the numbers as we go around here. But back to 3 pi/2, I get myself another vertical asymptote. And if I start winding myself negatively around the circle, if you will, okay, as I go to negative pi/4, I get -1 again, and then as I get to the negative pi/2, negative pi/2, I actually get another undefined, so there's where another asymptote shows up. Alright, so basically you can see this little almost diagonal line looking thing, but again, thinking of what our graph looked like a second ago, we do have this nice little wiggle going through here. I'll admit I don't do it very well by hand. Those of you a little more artistic than me can probably do a little better job, but it should come up here and kind of makes one of those cubic looking graphs, so kind of like our barrel of monkeys graphs, but it's actually just a repeated pattern lined up one after the other with asymptotes separating them. But anyway, that's why it looks like it does. Okay, so now moving on to cotangent, well, it's as simple if you have the right calculator, typing it in, and again, something spits out like this. Just like tangent, though, these vertical lines that may or may not show up depending on your software and or model of calculator, And there's one right here that's hard to see, but we got another little separation right there. We've got all these nice asymptotes, and again, just like the tangent, we've actually got little arrows going on these guys, but I'm going to save time and not bother doing that now. Alright, thing though is, if you have a TI 83 or 84, you can't simply type in cotangent because there is no such thing as a cotangent button. On the Inspire, you have that. So if you're talking about a TI 83, 84, what you need to do is actually realize that cotangent is the reciprocal of tangent, and type in for your y is 1 divided by tangent of x, and when you do that, something similar to this will spit out. So anyway, just be careful, depending on your model calculator, you have to handle a little bit differently, but anyway, there it is. Now, in order to, again, kind of demonstrate why that is exactly what it is, we'll take a look at the unit circle again. Alright, and tangent and cotangent are very similar because of the fact that they're reciprocals of each other, but, again, at 0, okay, well now tangent is 0, and if you try to take the reciprocal of that, you get undefined. Okay, at 1, sorry, pi over 4, you're going to get 1, and the reciprocal of 1 is still 1, so nothing too exciting there. Okay, here, normally tangent's undefined, but again, we're doing the reciprocal of that, and I know it's a little bit weird to say so, but like the reciprocal of undefined, at least in this context, is going to be 0. Okay, over here, I get -1 for tangent, reciprocal is still -1, and as I make it over to pi, we have kind of the same thing as 0, is we normally would have 0, but since we're doing the reciprocal, it's undefined again. Again, continuing that basic pattern around the circle gives me a +1 here, gives me a 0 here, and then over here gives me a -1. Okay, so now translating that to the graph, again putting a tick mark for 1 for -1 here. Okay, notice at 0 I have an asymptote, and so just like what the calculator spit out a few minutes ago, that's where we have our first asymptote, so there's like no good starting point, at least in terms of something on the y-axis, because it's undefined there. Okay, but as we continue around the circle, we've got our pi over 4, and we've got our pi over 2, and then a 3 pi over 4, as we basically do the top half of the circle before we get to the pi, which gives us another undefined, therefore another asymptote. We get that, and again, notice the pi over 4 gives me a +1, b pi over 2 gives me a 0, and then the 3 pi over 4, I'm kind of writing in my units, I apologize, gives me the -1. So again, that's why the graph looked similar to what it did there, as it comes through, passes through the x-axis, and then drops off the table in a negative direction. Alright, so it basically takes the tangent graph and kind of reflects it and slides it over, because normally it'd be here doing a barrel of monkeys, but here's kind of our negative barrel of monkeys switched over to the right a little bit. Okay, continuing around the circle here, or actually, let's do the negative values because that'll make a little more sense. So the negative increments of pi over 4. Okay, again, symmetry going on here again. So as I go to negative pi over 4, I'm actually sitting at -1. Okay, negative pi over 2 puts me at 0. Negative 3 pi over 4 puts me at +1. And then the negative pi, again, is undefined, so that's going to represent an asymptote for us. And again, notice the same basic wiggle pattern just continues on. So there's what our cotangent looks like, kind of done by hand, and again, you can generate that pretty quickly if you at least have a basic idea what the graph looks like and can do some simple unit circle values. Alright, now it'd be good to establish some general rules for tangent and cotangent, very much as we did for sine and cosine. So with the same basic setup with the various A, B, C's, and D's mixed into the potential spots where we could put them in the equations, alright, some various effects definitely happen. For instance, I'm going to say amplitude in quotes because it's technically not an amplitude, because the tangent and cotangent both go basically to positive infinity and negative infinity, and amplitude really implies that you kind of go up and then back down. But if we kind of can catch my meaning here, the amplitude is still going to be your A value, which is effectively just a vertical stretching. Alright, the period is, and if we think about the graphs again, period, we actually did one full period in pi distance on the x-axis, but just like with the sine and cosine, we're going to have to modify that by dividing by the b value. Okay, so please do take note, the period here is different because instead of 2 pi over b, it's actually just 1 pi over b. Alright, the horizontal shift is still going to be the same thing, left or right depending on whether this guy's lying or telling the truth, and then c divided by the b value, and then again the vertical shift pretty much staring you in the face with a d. So the only difference here is that it's not really an amplitude, and then the period, instead of having a 2 pi, it's just a 1 pi. Alright, now graphing these guys by hand. I'm giving you a list and I'm not going to read through the whole thing, but I put a lot of quotes in it because, again, because I don't truly have an amplitude, some of these things are a little bit not exact, but there they are. The only difference is, and I did this in a different color, hopefully on your screen you can tell that, but the number 6, okay, all we're going to have to do is draw on the vertical asymptotes different than what we did with the sine and the cosine. So other than, of course, doing the basic shape of the tangent and cotangent, the basic steps are going to be the same as establishing kind of like the framework, if you will, before we actually draw in the curves. Alright, so let's put one of these things into action. Okay, if I've got a graph, y equals 2 tangent of x minus 3 by hand. Okay, and I want to establish the various facts about this guy, and then we'll put them onto the graph. Okay, so first of all, again, not really an amplitude, but kind of a vertical stretching, is 2. Okay, just to get your a value. Okay, our period, okay, it's going to be pi divided by our b value. In this case, there is no b value, so of course understood to be a 1, so our period is simply going to be pi. Alright, which means our quarter periods are pi over 4. Okay, and then for as far as shifts go, okay, I've got this minus 3. Notice it's not in parentheses, so it's not a horizontal, but it's a vertical shift, so our shift is going to be down 3. Okay, and then again, I also want to consider any reflections that we might have, and in this case, I don't have a negative in front, and I don't have a negative inside on the x, so our reflections are none whatsoever. Alright, so that being said, let's put all these things on the graph. Okay, first thing first is our center line. Okay, so again, I'm going to go down 3, and my amplitude, if you will, is 2. So basically, by going down 3 and then 2 more of my amplitude, I want to go down a total of 5 as far as my tick mark spacing goes. So I'm going to go 1, 2, 3, 4, 5. Again, the 3 being my center line, so I'll see if I can make this reasonably straight. Alright, and then let's change colors just because that's fun. Alright, so 2 more down because that's my amplitude, gives me kind of my minimum line, and going 2 up from negative 3 puts me at negative 1 for my maximum line. There we go, a little downhill there, but hopefully that makes sense. Okay, so there's that. Okay, horizontally there was no shifting, which makes it nice. Okay, so my quarter periods are pi over 4, so I'm going to kind of start in the middle here, and then go pi over 4 repeatedly for my quarter periods. So let's go black for this one. Okay, so quarter periods, so 1, 2, 3, 4 quarter periods this way, and then 1, 2, 3, 4 quarter periods that way. Okay, for this one I actually am going to add on to this a little bit because of what's going to happen, and just as foreshadowing, I'm going to put 2 more tick marks here to the right, but we'll get there when we get there. Okay, but anyway, this will be a pi over 4. Okay, 2 pi over 4s is really pi over 2. Then I'm at 3 pi over 4s, 4 pi over 4 is really pi, 5 pi over 4s lands me here, and then 6 pi over 4 is actually a 3 pi over 2. Okay, going in the negative direction, I've got negative pi over 4, negative pi over 2, etc. Okay, so at this point, start thinking about where our basic graph is going to go. And again, the vertical asymptotes for tangent, and I'll admit I kind of like to do this with my center point. Alright, there's my starting point, because again, that's how that works. And again, my tangent graph is my barrel of monkeys graph, so I'm going to start low and kind of work my way high, but then I need to hit an asymptote and kind of skip along as I do this. So at the middle, I go to the high point, and from there I kind of barrel of monkey my way into an asymptote. Okay, so there's an asymptote there, and once I make it past the asymptote, I drop down to the bottom, and then come back to the middle. Alright, so basically there's one period to the side, but I admit this one's a little bit awkward because the asymptote kind of goes in the middle of it. But just continuing the pattern here, going back the other direction. Okay, if I'm at high, I'm going middle, now I'm going low, and then I hit an asymptote. And then again, I would add my asymptote and then start at the top and go back down to the middle. Okay, so again, I put these other tick marks here because 2 periods of tangent is a little awkward when you have these asymptotes cutting the periods in half. So I'll admit what I kind of like to do is do the one that kind of goes through the y-axis and then do one more to the right, because right now if I complete my graph, what I actually have is this kind of half of a monkey here, I have another full monkey in the middle, and then again on kind of the right half I just have simply half a monkey, which I think just looks a little bit weird. So if I just simply continue the pattern over here to the right, I end up with the other part of my monkey and another asymptote serving as kind of like my end boundary, if you will. And that's a really crooked monkey. My apologies to the monkey population of the universe. But there you go. So realistically for me, I wouldn't bother with this guy on the left, and I would do one through the middle and then just kind of extend it to the right a little bit, because I just plain don't think that looks nicer. Okay, now let's take a look at how cotangent plays out when you graph this thing by hand. Okay, again, same basic information I'm looking for, but again, since I'm dealing with cotangent, I am going to have a little bit of a different graphing experience here, but let's go. Amplitude is going to be our 1/3, our period. Okay, again, it is going to be pi. There's no modification there in front of the x, so that's it. So that leaves my quarter period being at pi over 4. And then my shifts, nothing vertically, but I've got a horizontal big fat liar going left of pi over 4. And then reflections, fortunately none of those to have to worry about on this particular guy, so there you go. Okay, so again, we'll set up our vertical, horizontal sort of deal. Alright, so again, nothing vertical, and then I've got a 1/3. So to make that look reasonably nice, what I would probably do here is put a -1 and a 1, and then do my best to split that into thirds. So there you go, and there we go. Okay, I'm going to change colors to help highlight this, but my center line, since there's no vertical shift, is still going to be right along the x-axis. Alright, and then again, if I'm going up and down 1/3 for my quote-unquote amplitude, that puts me at the first tick mark up and my first tick mark down. Okay, and then from there, okay, I'm going to shift left pi over 4. So again, just to help highlight this, let's do a nice pretty pink one. There we go. So I'm going to go left pi over 4, and my quarter periods are pi over 4 as well, which is kind of nice that that's equal, so I don't have too much to worry about here. But here's my negative pi over 4. Okay, and then shifting back to, let's go black here. If I continue pi over 4 in either direction, okay, 1 pi over 4 here, I'll kind of darken that in to help highlight that that's a point that I'm interested in. Another pi over 4 is now my second in this direction. Third one is going to be 2 pi over 4, of course that's pi over 2 again. And one more gets to a 3 pi over 4. Okay, going in the negative direction here gets me a -2 pi over 4. Again, that's negative pi over 2. -3 pi over 4. Okay, notice that's only my second in the negative direction, so I've still got 2 more. Okay, this gets me to a negative pi, and then one more gets me to a -5 pi over 4. Alright, so let's start plotting some points here. Let's pull out our green marker. Okay, now cotangent. Okay, again, normally cotangent has an asymptote right on the y-axis, but it's been shifted over to this pi over 4. So really, there's my start, if you will. Okay, again, kind of hard to call that a start, I think, because it's an asymptote, really, but let's deal with it. Okay, and then cotangent kind of starts high on the left, and then wiggles its way through kind of a monkey fashion again to go lower right. So at my first quarter period off of my starting point, it's going to be at the high point. Next quarter period takes me down to the middle. Third quarter period takes me to the bottom of my quote-unquote amplitude. And then finally, by the end of my quarter period again, I'm in another asymptote. Okay. So cotangent's kind of nice that it gives you a complete curve within the one period instead of being kind of split in half like tangent is. But here we go. So drawing my monkey this way gives me one curve, and I just need to do one more. Again, as I work my way to the left, if I can think of this asymptote here to kind of mirror from, I start low as I'm working my way left and work my way back high. So from this asymptote, my original starting point, I'm going to be low here, middle, and then high before reaching another asymptote here at 5 pi over 4. And again, just draw a nice smooth curve through there as best you can, and you've got yourself a pretty accurate cotangent graph. Okay, again, any skeptics out there and you're like, oh, that makes no sense, Mr. Osborne, well, yeah, please just set your window up appropriately, type the equation in the calculator, press enter, and you should get a nice picture like that without quite so many fun colors. Alrighty, here's the assignment. Okay, it's not a ton, so hopefully we don't have any trouble getting this done in class, but given that, please do take your time, make sure you actually have them right, check your answers, and then actually, I know this is a shock to some of you, actually ask for help if you're not completely sure if you're right or wrong. Alright, there it is. Again, please ask for help if you're even slightly confused. See you in class.